Before we start talking about the lateral movement part, which is this session, I want to just connect back to some of the stuff that the guys did in the first one. Because it is important to understand how realistic this is. I think there's a certain spice about doing everything live on the keyboard. So this is actually, going back to the Malmö case, this is the actual desktop of one of the computers when the police entered the apartment of the suspect. So he was somehow very efficient in getting money stolen and getting money out and things, but he wasn't that efficient in protecting himself. So he should actually have attended more sessions in protection, not just attacking. Anyhow, this is the desktop, and it's interesting to understand the demos that, for example, Kenneth did with the Empire. These are live sessions of screenshots from the threat actor when the police entered his apartment. So these are actual live connections to machines he was controlling at the time. So you realize these demos are the exact things that are happening in the real world. And there are more of them. And it's kind of interesting if you look. He was using Empire. He was also using Metasploit framework. And he was using modules, for example, the lasagna, to extract username, credentials, and stuff. So, and this is also interesting. This is from the police report. You can actually read real passwords, links, and usernames in the police report. That's another story. But it's reality. So if you somehow get hacked, make sure you have your shit together. I didn't say that. But it's really interesting read. You can see all this stuff. You can see that they actually used the macros. This is the real macro they were using to execute code. This is Empire, obfuscated run code. But with that in mind, we switch over to the lateral movement. But this is so applicable. If you ever had ransomware, then someone executed code on your internal environment. So let's see what we can do from there.
That's right. So we're going to connect back to the previous session. And we're going to try to take an overview at the end. From the attacker perspective, and also how to proceed from there as defenders. This is going to be mostly a demo session. I just have a couple of slides to set the stage and give some context. If you see any errors or mistypes or stuff like that, that was probably my one-year-old last night when he was playing with my keyboard while I was trying to finalize the presentation.
Shh. Don't talk about that.
No, I shouldn't, right? Well, maybe one day he's gonna, find software bug and stuff. For now, he's just trying to break the hardware.
Is that in the Italian blood? You have to make confessions, like the Catholicism or something?
Yeah, we'll see about that.
Okay.
Anyways, let's give some. Let's see what we're gonna talk about. We're gonna give some context, and then we're gonna do some demos. We're gonna basically take the position of a victim, of an attacker that infected a client. It's the one that David and Kenneth infected in the previous session. And we're going to take it from there. And then we're going to wrap it up and also visualize some dependency on a higher level, try to take an overview approach to it. So to go back to this attack path picture, now what we talked about, or what my colleagues have talked about in the previous session is, this first part of the path, right? So taking the entry point. And, they have combined exposed servers vulnerability. So they found that vulnerability in the web application. They exploited it to run code, and they used that to conduct a client-side attack against the user device. So now what we're going to do, we're going to take it from there and focus on the next two steps. So taking internal systems and compromise the entire infrastructure. And this is based on, what we see when we do pen tests, when we do red team exercises, when we do security assessments in general. This session, and I think the most value of this session is that this is not really going to show like some crazy fancy techniques. This is going to show the real things that work in the majority of cases. So this is the reality. This is really what makes a big difference between taking the initial foothold, so going through the entry point, whichever that is, and escalate the internally, because internally it's usually very easy, or at least it takes, well, I would say on the average organization, it just takes hours or days, I would say, in a more optimistic view, to escalate from any user to compromise the entire network. And this is just the reality. This is what we see and what we do. So we're going to act in this context. So we're going to be a regular user in a typical Windows domain. So this is the case if you're either in a threat actor that managed to get an entry point to infect the client, for example, and act in the user context, or we can already be an employee that want to do malicious activities in the network, or we can be some other external party that has an account and access to the network and want to do malicious things, or maybe they are compromised and they're used as a way into your environment. Or you can lose a computer with credentials, the computer wasn't encrypted, and so on. So any situation that puts you in the position of having a regular user account and internal network connectivity, this is where we start. So it's a pretty broad range of threat actors that can potentially be here. So we're going to start with the demos. We're going to attack corp.local. And the phishing attack has already been done. We compromised the embargo client. And we have a shell. So what we're going to do is we're going to jump into Leon Varga's computer and see what we can do from there in his context.
And remember, you don't have to be a local admin to do all the stuff that we do now. A regular user is enough to execute code, upload, download things, and have a really, really nice platform on a target computer.
That's right. So actually, we can see, verify that. If I do a who am I, I'm Leon Vargo. If I check net user, Leon Vargo, leon.vargo/domain. So in the domain, I have a membership just in the domain users group. So I'm just a regular user. I don't have any membership to any special group or anything like that. And well, we can check on this local workstation if I am a local administrator or not. Well, local administrators on this machine are admin, administrator, the domain admins, and a test user. That's an issue in itself. But we are not domain admin. Sorry, well, we're definitely not domain admin. We're not local admin on this computer. So, yeah, so let's take it from here, see what we can do. Now, as a regular user, there is a whole lot of information that you can get from the domain that can help you very much if you want to do, well, not only malicious things. I mean, you can collect information for various purposes. Now, from the attacker's perspective, there is a whole lot of things you can gather as a regular user that you can use. And you don't need any special tools for doing this. You can use built-in commands. So what we normally do is we combine different scripts and tools, and we package them in a way that make it usable and quick for us to execute and get the overview of the environment. So this is an example of running through one of our scripts. We're going to use something that we call Remote Job Toolkit. We're going to create a session for this particular domain we're in right now. So corp.local. We're not going to go into any details of this. We're just going to show, a small part of it. The way this works is basically we're going to execute different functions, which are going to end up in a variable called session. We're going to have the domain and its information. So I can basically just start to get information about the domain. So I have my first domain in this session is corporate local. It's the only one we're going to look at right now. And now it has a variable called domain, which has the typical domain information. So I know the forest, I know, which domain controllers there are, who has the PDC role, and so on. So just regular domain information. As a regular user, I can also get all the computer information, all the users, all the groups, and all of that stuff that is just readable by any user by default. So let's gather all the computers that we have in this domain. Done. Now, this is a small domain, but it goes almost as quick in an average size domain. I can also get all the users and all the groups. Let's do that. Done. Now, you don't see this because it's all stored in the session, but if you want to start outputting things, if you want to get, for example, let's get all the computer in this domain and take the name, distinguish name, operating system, and so on, and let's try to get the overview from there. We just run this function, and this will just output everything we have in our session right now. So we have the complete view of everything that is in this domain. We have some servers, some clients. These are the different versions of the OSs that we have when they were created, and so on. That's obviously when I was working on these demos, that date. Let's see. So we have computer information. We have users information. Get some general user data and properties that we can see here. We have things like, typical user information. So account name, display name, description, last logon, and password last set, which is also very interesting. So just as a regular user, you can grab all the password last set attribute of all the accounts and see whenever anybody has changed their password last time, and try to get an overview when you find that service account in the domain admin group that hasn't changed since 2003. You may start guessing what password that could be. Not that any of you could have that type of account in your environment. All right, so again, we're not going to go through all of this. This would take a week just for that, but we can get a lot, right? So just with this information, we know what type of accounts we have. We know what privileges they have. We can, of course, also check the group membership and do that recursively. We know when they change their passwords. We know any property that they have. We know what computers they have, what version they're running. We know what they're called, which can be enough sometimes. We know what OU they are. So if they have a test OU, maybe you want to go towards that first, for example. What do we do from here? Well, again, there are many different things we can do as a regular user. Let's start with one. Services that are running in these computers, they often are registered in the domain, and accounts have SPN properties, so service principal names. That's also something we can read as regular users, so we can see what services are running where. But there is something more that we can get from there, actually. It's actually an attack against how Kerberos works. This is nothing new, but it's still very applicable. The attack is called Kerberos, and it has to do with the way that tickets are well, the flow of getting tickets and access to services in Kerberos. It's not really a vulnerability in Kerberos itself. Well, I'll go back to that. But basically, when you want to access a service as a user in the domain, without going into any detail at all, you basically request a ticket, or TGS, a ticket granted service ticket, to the KDC, or K Distribution Center, which in Active Directory is the domain controller. And the domain controller will give you a ticket that you can use to access a certain service, and then you bring that ticket to the service, and the service will decide whether you have access to it or not. The interesting thing about that is that that ticket that domain controller gives you is encrypted with the password or the hash of the password of the service account that you're requesting access to. So that means that you can take that ticket, you can just request any ticket, take it, bring it with you at home, and put that into your cracking machine, and crack that service account's password offline, because the ticket is encrypted with the service password. So that's just something you can basically collect, go home, and start cracking. So we have one function here that basically does this whole thing behind the scenes. So you won't really see anything. You're just going to call something called get service tickets for a certain domain. You run that. Now we have all the service tickets ready to be cracked. If you want to see what they look like, let's go down to service tickets. These are what the interesting ones look like. We have the account for which the SPN is registered. And we have the actual SPN entry. So we know, for example, that Web01 runs a service on port 80. There is an HTTP service. Then we have SQL 1, 2, and 3 running a Microsoft SQL service on the default Microsoft SQL port. And in addition to that, we also have the hash, which is basically the ticket that we can crack. So what I'm going to do now is to take this ticket and export it just to a text file in a format that I will give to another tool I have to crack. So we'll just create a text file. And if you just want to look at the content, this is just a simple text file which contains different lines. Each line has the entry that we got from the service tickets function. So I'm going to pass this to another machine right now. I already copied that before, just to save some time. Let's see, one of my million windows here. All right, so in this function, I have that, in this folder, I have that text file, which looks just like before. And I also have a list of the 10,000 most common passwords, in case any of those services have a password that is in that list. If not, increase the list and repeat. Let me do some copy-paste hacking to save some time again. We're going to run a tool called John.
John the Ripper?
John the Ripper, yes. We're friends, so I'm calling with a short name.
Of course.
So I'm going to tell it to please use this format to crack the tickets. And use a word list and take the tickets from here. So let's run this. And that took a fraction of a second to find the password for the test service account, which is testing. What a surprise. In a more, in a more realistic case where, well, no, I wouldn't say realistic. This is pretty realistic, unfortunately. But in a more difficult case, this could take even days. But again, this is something you can do offline. So you can just grab those tickets, have a powerful enough machine to make this fast enough, and just run it through it for days.
What is the important take-home from this example? I think, from my experience in doing investigations, it's a very big take-home. It's the fact that you get infected on one client machine. And maybe you find the malware there. Maybe even your antivirus, after a certain point in time, finds that. What is the normal course of action? Do you do an investigation? Or do you just remove the malware? So in this case, the attacker, he ran a crack on service account hashes, and he cracked the hash. So he has another account. He may have moved on, and you're just deleting the only evidence of the first entry. So I think this is very good food for thought to think in terms of, okay, we have malware. What happened before that or what happened after that? Especially the latter.
That's a good point.
Thank you.
And we work together.
We do.
So let's go back here. That was one example. Now I'm not going to dig into this service account just to save some time. I'm going to tell you that's just a regular domain user. So we already have a shell in regular user context. We're not really gaining anything with this account other than hiding our traces, really, because now we can start using a different account and proceed from there, just like you hinted there. But let's look at another thing we can do as regular users. There is something called group policy preferences, which, well, I'm not going to explain so much of that, but it's basically something you can set as a policy in your domain. Things like, for example, tell anybody hit by this policy to run a scheduled task every time they use a log on, or to mount a share, or whatever type of setting you want to issue through a policy preference. You used to be able to set an account to run that configuration with. So that's, for example, if you want to run a scheduled task once a user logs on, but you want to run something that the user normally doesn't have permission to do, then you can give that username and password. Well, you can include that in the configuration. That's going to be pushed to all the systems with the policy. So that will contain the password. It's encrypted. Unfortunately, the key is public. So it's actually AES encrypted, or I think it's AES. It's symmetric encrypted anyways. And the key is public. It's actually on Microsoft's site.
So this is a legacy way of doing things.
That's right.
Storing a username password that way, it actually gives you a warning if you try to do it today. What's interesting is that in, I would almost say 50% of the cases we do a big red team exercise or pen test, we find one of those. And it's valid and we can use it.
Yeah.
And sometimes after doing the reporting, they said, we don't have that. Yes, you do. Okay, we didn't know.
Yeah, the thing is, with the latest versions of Windows, you're not allowed to even do that. So you can try. Well, actually, it's grayed out that setting. When you create a policy, you can't even attempt to enter credentials there. In other versions, I think 2012 R2 and 2012, I'm not sure about 2008, but you actually got a warning. When you do that, it tells you, yeah, the password is obfuscated, but it's still discoverable. That's a way to say that it's encrypted, but the key is public. And before that, you didn't even get a warning. You just enter your credentials, and they were stored there. Now, when you go and remove all of this, well, when you stop doing that, you also need to remember to go and remove all the ones that you had before. So that's something that sometimes organizations miss, and that's why we find this type of things. So we're going to run this function, which, again, took another fraction of a second. This basically went on the domain controller and asked for all the policies and parsed them to see if any of those contains credentials. The credentials, if you look at it, is encrypted, but this function already applies the publicly known key to the encrypted and just gives us back the clear text. So that's just some manual work that is put into a function to automate it. And we can view it down here. Grab to output the group policy preference passwords. And here we have one with username corp updater. And this is the clear text password of that account. And this is the file where it was found. So it's a scheduled task.
Something to go check if you still have it in your environment.
Mm-hmm.
And what credentials do you need to extract it?
Any regular user can read the policies, and these are stored in the policies, and the key is stored for everybody on the internet. So any user in the domain can do this. Let me see if I can reach that file, scheduled tasks. Actually, I have it there. If you want to look at the actual file, the actual policy file, it's an XML file containing the scheduled task, you can see there is a password here, which is encrypted. But we apply the key and we get back the clear text. So again, this is nothing new. This is actually pretty old, but we find it a lot. So it's always something to check for. So that's called corp updater. So let's see, net user corp updater / domain. See what we get. Well, here, this user is actually a domain admin. But let's not make it so easy on ourselves. So this account is actually not active. All right, so this is some leftover. The account has been disabled, so it's not as big of an issue, obviously. But yeah, it just shows you the point. This is how it's done. It's very simple from an attacker perspective. You query the policy, grab for password, decrypt them, you have them. All right, now one last thing from this perspective of the regular user trying to escalate the privileges. And it's something I'm sure all of you can recognize, network shares. Nothing strange about it. There are files and resources, folders on the network you can access with your privileges or, yeah, depending on what group you are and so on. It's typical to find these big shares, this common shares where anybody can share data within the organization, and you can try to look for something interesting in there, or there can be servers sharing some folders that were maybe not supposed to be shared to all users, or maybe it was done just for convenience, because it's so easy to just set, yeah, everyone read. Fine, that's yeah. It works, so why not?
It's pretty often everyone read and write, actually.
Yeah, we'll get to that. So let's try to find out first what shares we have available in this network. So we're going to run a function called getNetShares. This is going to go out on the network and basically ask each system what share they expose. It's basically just doing a net view for those of you who know, or yeah, equivalent type of query. And come on, hit that. So then we can list them all. All right, so these are all the shares we can access. We have the default shares, so admin dollar, C dollar, IPC dollar. Then we have the default on the domain controller, where the policies are and so on, and the scripts, yeah, some other default shares. And then we have a server called FS01, which most probably stands for file server. That has a backup share, a common share, a data, IT, and software. These are all shares that, from the perspective of attacker, can be very interesting if we have read access to it. We don't know. So we're going to run a small function. Well, actually, first, we're going to select which shares we want to search through. So I'm going to select the file server shares, the common share, the data, IT, software, and backup. I'm going to click OK. So now I have a list of shares. This shares to search function. Yeah, then I'm going to pass to another function. So basically, I'm going to tell you, can you just go through these shares and search for all the .config files and .vbs files? And you can add .txt, .batch, .cmd, .ps1, whatever. And in those files, can you look for anything that matches password or connection string? And give me the results. Now, in a big network with big shares, this could take several hours, depending on how much you want to include in that search. You normally start with just very narrow search. Maybe you get lucky in 30 seconds, and then you expand, right? So now we have a result. That share searches. We print all the results that had those hits. We have a few. So each of these ones is a different entry. So we have, for example, in a file on this share called web release config, we have something that matched the word connection string, and the line was just closing of the connection string tag, so not so interesting, but of course we're going to have this false positives. We need to go through them. We have another one where we actually have a connection string. It's in the same file, but they use integrated security, so we don't have any clear text password. We can scroll through this. We're going to find some not so interesting stuff. And up here, actually, we have something way more interesting. It's something that matches the word password. And it's in a SQL Sync Service Installer script. And that's the line. It's running the setup, passing username and password to it. So that was part of the whatever SQL installation service that was.
But again, looking at the key learnings here, you can be very strategic. You don't have to manually go through all your big shares and files. You can run some script and just extract this information from a huge amount of data. So that's what you should think about. Do we have this stuff in our own environment?
Answer is probably.
From
our experience. And of course, what you get, it depends. It varies very much. Sometimes you get something you can't really use. Sometimes you get a domain admin password, and everything in between. So it depends. Let's see what we have now. We have something called SQL Sync SVC account that we obviously have the password for, provided it's valid. So let's see what account that is in the domain. Net user, what was it called again? SQL Sync Service /domain. This is just a domain user again. It is active. So it doesn't look like we have got any more than what we already have. However, we don't know where this where this account is local admin to. I mean, it's a SQL service account. It may very well be local admin on some SQL servers, right? Let's try to find that out. I'm going to just do a run as in that user context now, because I know, sorry, that was the wrong one. Scroll a bit more down. I'm going to do a run as the SQL sync service. And I'm going to paste the password I got. Now, from here, I'm the SQL sync service. I'll make this a bit bigger for you guys to see better. I'm going to import my module, my PowerShell module that I've been using that has all my functions. And I'm going to do something called find local admin access. Dash verbose. This will go through all the hosts I have in the domain, and it will try to figure out if that account that I'm running as is local admin to any of the servers. And we already have 2 hits. We have SQL1 and SQL2 that we're local admin on. And that's a big yay moment from an attacker's perspective. This is really the big step from when we move from a regular user account on any whatever client to being local administrator on at least one server. That's a huge upgrade, and it's going to be very obvious why in a moment.
So the difference between these examples and the ones we normally do is that this is what it looks like in the real world. It's not just go onto a workstation, find the domain admin logged on. You have to take these steps in order to find something, and this is what you need to understand. So even though you only have one small crumble there, one other crumble there, an attacker will tie them together in order to become a domain admin eventually.
That's right. So we started with some enumeration. All the computers, all the users, and so on. You've seen that. And then try different strategies. We went through the group policy passwords. We went through the service accounts. We cracked some. Didn't give us much. Well, actually, we could check for that one be local admin anywhere. We haven't done it. We could do that too. We found some password in some file on a share that we could read. We used it and figured out we were local admin on 2 servers. So now we have potentially the possibility to run code on these servers as local administrators, provided we can reach them from where we are. All right, so we're here. So what do we want to do from here? Well, of course, the idea is to move forward, right? Well, of course, we want to jump on those servers and see what we have. You know, that's the feeling you get as soon as you have access to something. Yeah, let's jump on it and see. Sometimes you can't really do that right away. You need to act more stealthy. But so, again, like David was saying, it's like a child. You wanna, you just wanna get to it. But you need to do it strategically, depending on the position you are at the moment. Right now, we can actually just try to execute code on it. But what do we want to do with that code? Well, we want to extract credentials. So now we go into the whole area of credentials and dependencies, which is a huge area which I'm sure a lot of you have heard about. We're going to see it here with live examples. And we're going to go back to this point a lot, not only in these sessions, but in other sessions too, because it's very important. So we're going to extract credentials. How do we do that? Well, first we need a way to run code. Let me zoom this in a bit. I love Notepad. So there are different techniques to run code on a remote system. A lot of you have probably heard of PSXSec, a sysinternals tool that uses SMB to run code on a remote system. There are different ways than that. One is remote WMI execution, which is actually better from a stealthiness perspective, because PSXSec installs a service on a remote system. WMI does not. It basically queries the RPC servers on the other side and then negotiate another port to talk. And then it will issue a remote WMI command. WMI is a huge, I don't know if you should call it framework or...
yeah, it's a remote administration framework.
Yeah. It has a lot of different functionalities, including starting a process. So you can tell a remote system, provided you have correct and valid credentials, to start a process and tell it which process that is. So that's remote code execution. So we're going to define the credentials that we've got, so with the username and password that we got from the file. I'm going to take this a bit higher up. Maybe it's easier for you to see, especially in the back. All right, so I define my credential object. I can just pass it to my function now, invoke WMI method, give it my credential. I'm going to tell it to run against computer SQL 01, and I'm going to tell it to run whatever. In this case, I'm going to start CMD and pass it a command parameter, task list, and output that to a text file. And then just check that file is there. I'm actually going to skip that part. It's quite boring. I'm going to go to the next, more interesting part. We don't want to run task list and put it in a file. We want to extract credentials and get those credentials out on our attacker machine. So this is how we're going to extract credentials. We're going to use PowerShell. We're going to go back to it again and again and again, because PowerShell has a lot of nice things from the attacker's perspective. One of them is running things in memory, in addition to be able to invoke the entire .NET framework without writing your own binaries and so on. So what we're going to do is we're going to download a script called extract else's credentials.ps1 from an external machine, in this case the attacker machine, and we're going to pass that to something called invoke expression, which will basically interpret whatever is defined in that script.
And it's important to understand, it says download strings. It doesn't say download file. So you don't put the file on disk. You execute the file directly in memory. So there's no evidence on the disk of that file be running.
That's right. So what this function does, just to make it short, it's going to extract credentials and upload the result back to our server on the internet. We're going to basics for all that PowerShell command. And we're going to pass it to our invoke WMI method function. Tell it to go on SQL 1 and run this big PowerShell encoded command, which will do this. All right, extract credential and upload them. So if this all works, we should be able to see the files coming to my server here. And they're going to appear in this folder when they're stored. So let's do that.
And while it's doing that, think for a second. Think, could we detect this? Would you have any chance of detecting the fact that he's downloading this extraction function from the internet and executing it in your environment? I think you know the answer.
You made them so quiet.
Someone has to bring them down.
Yeah, sorry. Well, I'm not trying to bring you up.
Well,
now.
we're just promoting tomorrow when we're going to talk about how to implement security. This is the problem today.
You have a point. Fine. So we've run this now. So if all worked well, which seemed like it did, we downloaded the file and then we posted some data back. So now here we have a file called extractcredentials.txt. Let's look at the content of that file. This is the output of the Mimikatz tool, which we run in memory right now, for extracting credentials of logged on users in that machine, so targeting credentials stored within the else's process memory. So we can see that we have the credentials for the computer account, which is obviously running on that computer, and that's the NT hash of that computer account. You can scroll down. We have some more computer account. This is actually the clear text password of the computer account, which is auto-generated when you create the computer. Computer account, local service stuff, local service, computer account, and done. So that was pretty boring, right? So that also means that there is nobody actively logged on interactively, at least, to this computer for which credentials are stored in Elsa's for the period of that session being alive. We don't have that. But we do have one more option, right? We have another SQL server. So let's try from there. Actually, instead of doing this whole thing again, I can actually just check what processes are running on the remote system just to get an idea if there is anybody logged in with an interactive session that we can extract credentials for or not. So I'm going to jump on SQL2. I'm going to get the task list from that system using the same technique, remote WMI. And then for each of the processes, I'm going to request information about the owner. I can see I have some system stuff, network service, local service. And that's it again. So boring again. Nobody logged on with an interactive session, so not much we can do here. Now, actually, there is something we can do, and that is just wait. We can wait until somebody logs on. I mean, why not? If we have enough time to spend on this, we just wait here until somebody logged on. We steal the credentials, and we're good to go with whatever credential we've got at that point. But right now, I don't just want to sit and wait. I don't think you guys have so much interest in that part. So what we can do is to extract local hashes instead. And the idea is that instead of waiting for logged on users, we have local accounts too that are obviously stored on any system. There is a local database, the SAM database, where the accounts are stored with their hash. So we can extract it in the hope that those credentials are reusable on some other system, which happens if other systems are configured with the same local username and password. So let's do that. I think I'm going to have to run through this quite quickly. What I'm going to do, I'm going to mount a share with my credential on the SQL server. I'm going to create a temporary folder called loot in C Windows temp. And I'm going to run a couple of remote commands to extract the SAM database using regsave commands, so just built-in commands, into a file called samhive, and also the system key, which contains the machine key that I can use to decrypt the SAM database and retrieve the clear text database.
So if you find a folder named loot on your systems, you're in trouble.
Probably.
Always look for loot.
Yeah. The only thing you have to look for. And then we're going to upload them to our server. So I'm just going to run through this quickly. Boom, 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 done. Now, on my system here, I have samhive and system hive. Now I can use tools offline to extract the local database. Going to do some more copy-paste hacking and get this line. I'm going to use something called secrets dump. It's a Python script, part of the Impacket package, to extract credentials from system and SAM. And here is the local administrator password, or its hash, that we got from SQL1.
The interesting thing about this technique is he doesn't use any hacking tools on that system. So there's nothing that antivirus would normally detect.
No, basically just remote WMI and the regsave and copy file. That's it. Right, so we have this hash. Now, should we crack it and take the clear text? Nah. That's so old school, exactly.
Old school.
We don't need the password in clear text. We can just use the hash and do pass the hash. That's all the system needs to authenticate against services in Windows. So let's do that. I'm going to switch to a different machine because I want to run in a Windows context now as an attacker machine. In a real case, you would tunnel this connection through the compromised system. Right? So you have your own Windows box, and you tunnel that connection through the shell that we have here to reach the internal network.
And that functionality is built into every attack framework, even the free ones today.
Yeah. So what we're going to do is use Mimikatz now for doing this pass the hash. Again, now I'm doing this on my own machine, so I don't care what I run here. But just because I like it, I do it in memory anyways. So I'm just going to invoke Mimikatz in memory. And I'm going to run the pass the hash command. Basically, you tell it, do pass the hash, and I want to use the administrator account, local host, because I want the local account. And this is the password hash you should use when you try to authenticate to a system. This will pop up a new command prompt. Now, if I try to authenticate to a system from here, it will use the injected hash. So just to see that I'm not making this up, I'm going to open a different one. I'm going to try to authenticate to another system. What can I choose? Well, something I know, file server. Let's see if the file server has the same password for the local administrator as the SQL1 server. Doing past the hash. So I'm going to do it from this window first. See if I can try to do a directory listing on fs01.corp.local admin $. Well, actually, that failed already. But I'm just going to want to do it right. Admin $, username password is incorrect. If I do this from the past the hash window, that works. Boom. That's what we say in this case. So we have a local password dependency, because they use the same password for the local administrator account. Now we also have the file server one that is compromised. We can run code again. We can extract credential, rinse and repeat. And well, let's do that just to complete the scenario. We're going to go, actually, we're going to stay within this window. From here, we're going to do the same type of credential extraction that we've done before, but from this context instead, or actually on file server 01. Let's run PowerShell in this context. And let's run my invoke my, which will tell file server 01 to download the script to run in memory to extract credentials, upload the result back to my attacker machine. And whenever this will be done, I'm going to end up with credentials, sorry, with files containing the credentials on my attacker machine here. And that seems to have happened already. I have a new file called file with a timestamp. Let's look at that. Now, I'm obviously running on file server 01. I can verify this because I have a file server 01 computer account in Elsa's here. Let's go down and see if we have something more interesting here. And yes, we do. We have someone called administrator from the domain corp, which is logged on to the system with an interactive session because its hash is stored in the Elsas. And that's the hash of the domain administrator. So we did have a happy domain admin logging on interactively on this server.
Happy right now.
Yeah, at the time of log on, it was happy, probably. Because it got the nice RDP feeling that you get with an interactive session, which also involves carrying your credentials with you to that system, just for an attacker to be picked up, which is what we did. So from here, obviously, we can reuse these credentials like we've done before, do another pass the hash, and close this one now. Now I'm going to do, actually, let me select it like this. In my machine, I'm going to provide now different credentials for the administrator in the corp domain. And this is the NT hash of the domain administrator that I got from file server 1. Now from here, I'm in the domain administrator context. So let's verify that. dc01.corp.local/admin $. Oh, I can't write that right. Admin $. Boom, domain admin. It's another thing we used to say.
They're picking up the lingo, man. It's coming.
Sorry. It just comes naturally. So we extracted credentials. Now we can, of course, compromise the domain controller. So classical, or typical, or classic, I would say, local password dependencies and high privilege credentials that we found logged on a system with an interactive session. It's been done in 2 different steps here. Sometimes, many times, this is all that's needed, just a couple of steps. In other cases, it can take maybe 4, 5, up to 10 different steps until you get to the account you want to get to. And it's interesting when you try to put this in perspective, because, I mean, this is just one path that we took. right? We don't know all the other paths that we could have taken. Once we manage to get code execution as local admin or local system on a server or whatever machine, we don't know every possible path that we can take to get to, in this case, a domain administrator, which is our goal. In other cases, it could be another group, depending on where we are.
And I think it's important to understand that, I mean, some of you guys work in security. Most of you guys are not penetration testers or hackers. Hopefully not hackers anyway, in that sense. I meant it right now. You don't have to be able to replicate all this, but I think it's really important to understand that these are the methods used for lateral movement. And still today, I dare to say that in 99% of the cases, just by understanding these different examples Fabio gave, you can go from one user to compromise an entire domain. In 99% of the cases. So these are the things we need to understand that they exist in order to mitigate. You don't have to be able to replicate them, but you need to understand that they're there. That's why this session is so important.
Yeah, so we use a couple of different ways to do that initial step, right, from a regular domain user to gaining additional credentials that could give us local admin access to another system or to a system. So we looked at Kerberos, we looked at password sorting group policy preference, we looked at network sharing containing credentials. I mean, if you just use these three, you're probably going to succeed in a lot of cases. But of course, there is a lot more you can do. This is not really the point of this session to go through all possible ways. But as soon as you have local system access to a server, then you use dependencies to escalate. So we try to get this on a higher level and try to visualize all the possible dependencies that we have in an environment. So we have a little tool we use for this, which is a visualizer of this type of problems. We have three different categories here to try and visualize. First of all, we can look at all the logged on users in a system. Sorry, in all different systems. Now, this is information collected from the system itself. So this has a white box approach. So with credentials that either we gain, and we want to get some more value out of our assignment, or that we are given because we're doing white box. Then we collect information from the systems, and we visualize the data we collect. In this case, we are collecting information about what accounts do we find in LSAS on a certain system, which is equivalent to, almost equivalent to who has an interactive session on that system. So, for example, this is the domain administrator. We know the domain administrator. We know the domain administrator was logged on to file server 1, because that's where we found it. But it was also logged on, well, on the domain controller, not too interesting, but on client 3. So if we compromise client 3 as local admin so we could extract credentials, we would have found the domain admin credential directly. Same thing if we exploited, or if we managed to run code as admin on Exchange server, we also had the domain admin in LSAS that we could extract and use. Right, so that's one side of the story. Another side of the story is the local hashes that we've seen a dependency for. Right, so these are groups of users that have the same password for the local administrator. We know that file server 1 had the same password as SQL 1. We verified that. It was also the same for SQL 2. It was also the same for backup 1 and 2.
And this is a tool and service we use at various customers, and sometimes these clusters are just gigantic.
Yeah, exactly. I mean, this is a domain with like 30 computers, so it's tiny.
Sometimes you can see 10,000 computers sharing the same password. And with this visualization, you make everyone understand it. That's when they start to change it.
Yeah, so basically you see a huge bubble somewhere, and then you figure out what system are dependent on each other. So all these PCs, for example, have the same password. So as soon as you jump on one, you can jump on all the others. Yeah. So now the third interesting part here is to put these pieces together. That's what we call lateral movements. This is what it looks like. What we do is we're targeting the domain admins now, or you can select whatever group you want to target. How do you become a domain admin from the systems in the network? So provided you compromise a machine, for example, let's take the machine we compromised, SQL 1 is down here, or SQL 2. SQL 1, what we can do is local admin, extract local hashes, and the administrator password was the same on file server 01, so we can jump there. Now, file server 01 has an interactive logon of the administrator in the domain, because we found it in Elsa's, so we can extract it from there and become domain admin. So that's the path we took. Everything else you see here is all the other potential paths that we could have taken to get from any of these systems to a domain admin member. So for example, if you manage to compromise as admin client 4 or 5, you would have found in Elsa's this user. You could extract it and use it. That user has local admin privileges on file server 1, which is where we found the domain admin, so we're back in the same path. Or it can be a bit more complex and use a couple of extra steps. If you take any of the PCs that share the same local admin password, you can jump to PC 1, which has a login of this user. This user is an admin on the Exchange server, and the domain admin was logged on Exchange server, so we can extract it and, again, rinse and repeat. So these are all the different paths. So it's again, in a bigger environment, there is a nicer overview of which area of the network where you have more dependencies, or which type of system. So normally, when you know your environment, at least you can recognize what systems do and what they have on them. So you kind of know, yeah, that PC is probably easy to get to, because I know that for other reasons. So, which is also something we can check related to another type of assignment, or another type of task that we're doing. But in this specific case, whatever reason that makes us believe that it's easy to get to that system, then we know we have a path to domain admin, and which one it is. And if it's something, if there is something that you know is valid, that you just want to remove it. So I mean, here you have the domain controller. You know the domain controller is not going to be a problem, because if you're on the domain controller, you're already domain admin. So you can basically just remove this and see how it changes. So you can make changes in this graph. So like this user, now I disable it. So how does that change my path overview?
It's also good for emulation if you want to change and be more strategic and take away dependencies. You can see where's the biggest effect of taking away some of the dependencies. So we use this for modeling and creating a more or less exposed admin experience, if you will. But it's a very good visualizer for this challenge. In many environments, when we run this, we realize that basically every computer indirectly exposes the domain admin. And that's when you know you have some work to do. So it's scary when you have 15,000 computers and you realize that 14,900 of them actually exposed to domain admin because of credential dependencies.
Again, this could take 15 steps in rare cases, but just to give the idea, maybe 50% of the systems have up to 3 steps. And then you have another whole lot of systems that take a lot more steps. So it always depends on the environment. But the point is, directly or indirectly, there is a path. So that's the problem.
Yeah.
So just to wrap it up.
Yeah, wrap it up.
We have gone through some common low-hanging fruits to escalate the privileges, and once we were a system, we exploited dependencies, which we visualize now, and it becomes more obvious that once we're anywhere there is a path. So it's just a matter of time until we find it. And visualizing really help. Getting the overview so that we can approach our work as defender with the right mindset, or at least focus on the right parts that really matter, because you can see where you have big parts of the network that have dependencies. You can easily visualize this, and then you can decide, okay, I'm going to focus on those first, or maybe just on that one, because I know that that one is easy to get to. I want to remove it right away. That must be critical. I do it now. Because we can't do everything at the same time. We need to do it strategically with a certain approach.
But I think from Fabio's perspective, he's a bit delusionized since he's been doing this pen test for many years now, and he always manages to do these attacks. Tomorrow we're going to talk about some of the new features in especially Windows in terms of killing dependencies in different ways, or actually making sure that you cannot even extract password hashes from systems and things like that. So there are, of course, solutions. There are also some organizations that take this very seriously, and they decrease the attack surface. But last but not least, there is always also a threat actor sophistication level. if you are a sophisticated threat actor, then you know all this stuff. Looking at the Malmö court thing happening right now, those people were good at sending those emails, but they were not sophisticated enough to do all this stuff. Maybe they were, but you can't find traces of that happening in all those environments. So you always have to think about what kind of threat actors do I have to protect myself from, and what are their capabilities? The only problem is that the tools are getting better and better, so nowadays most categories can use these lateral movement techniques. So you need to step ahead of the game. You need to start to find strategies so you can fight this. And that's what we're going to talk about tomorrow. Last but not least, I don't know, guys. I don't know how used you are to watching PowerPoints and things like that. That's really easy. If you only know how much it takes for Fabio to do all these live demos hands-on without failing, I think that deserves an applause. So thank you.